This lesson is on acid-base stoichiometry, most commonly associated with titration. All acid-base stoichiometry is going to be based on neutralization reactions. Neutralization reactions, you have an acid reacting with a base, and it's going to produce water and a salt. For example, carbonic acid and lithium hydroxide produce the salt, lithium carbonate, and water. All stoichiometry is predicated on balanced chemical equations, so you must make sure that it is balanced. Here we have 2 lithiums, so I need to put a 2 there. That gives me 2 hydrogens and 2 hydroxyls, so that will produce 2 waters. And then stoichiometry is based on these mole ratios from the balanced chemical equation. For example, if I had 2.2 moles of lithium hydroxide and needed to know how many moles of carbonic acid were equivalent to that, I would take the 2.2 moles of the lithium hydroxide, multiply by the mole ratio, in this case a 1 to 2 mole ratio. There is 1 mole of the carbonic acid for every 2 moles of the lithium hydroxide. That way moles of lithium hydroxide would cancel, and that would give me 1.1 moles of carbonic acid. So again, stoichiometry based on mole ratios. Background vocabulary for titration. Titration is the process by which you take a known solution, you add it to another solution to determine its concentration or volume. That known solution is called the standard, usually known quite precisely. And then the equivalence point is the point of the neutralization in an acid-base reaction. That is the point in which the molar concentration of the hydrogen ions that were present equals the molar concentration of the hydroxyl ions added, or vice versa. And so all of the hydrogen ions or hydroxide ions have been converted to water. The end point is the point at which the indicator used changes color, and that should be the same as the equivalence point, but you must choose the appropriate indicator that changes color at the point of neutralization for the particular acid-base combination being used. To give you an overview of the titration process, let's say I had a standard solution of sodium hydroxide known quite precisely, and I had an unknown concentration of hydrochloric acid, and I want to find the molarity of it. Remember, molarity is the ratio of moles per liter, and so if I want to know the molarity, I need to know the moles and the liters. To get the liters, I just choose a particular volume. Say I choose 10 milliliters, which will be 0.0100 liters. And so if I choose a particular volume, that then is my volume. My real trick here is how do I calculate the number of moles present? So what I do is I set up an apparatus that you see here. This is a burette. I take my 10 mils of my unknown hydrochloric acid. I put in some kind of an indicator that's going to change color at the equivalence point. I fill up the burette with my standard, and then I start adding the standard until I get to the end point. And let's say I had to add 20.0 milliliters of the base to reach the end point. And the endpoint we're hoping is the same as the equivalence point, which it is here. And so I use 20 mils. And so 20 mils is going to equal 0.0200 liters. And liters times molarity will give me moles. So 0.1 times 0.02 is going to give me 0.002. And then if I look at the mole ratio, for every 1 mole of this, there's 1 mole of this, so that equals 0.002 moles of this. And so now I know how many moles of the acid were present, and I know the volume of the acid, so that then allows me to calculate the molarity, which would be a 0.20 molar solution. So again, we use titration to determine the concentration or volume of an unknown solution. Go through some sample problems. What is the concentration of a 50 ml sample of hydrochloric acid, which is neutralized by 25 mils of 0.5 molar calcium hydroxide. Always the first step is to write the balanced neutralization reaction, which you see here. You need to take the information from the problem, write it down next to the substances. So we're using 25 mils of a 0.5 molar calcium hydroxide solution. We're using 50 mils of the unknown solution of hydrochloric acid. At that point, the standard is the one that you know both the volume and the molarity of, and liters times molarity will give you moles. So liters, 0.0250 liters times the molarity gives you the number of moles. Calculation there is going to look like this. So liters times molarity gives you moles. And so now we know we have 0.0125 moles of this. Now we have to figure out moles of this. We do that from the balanced chemical reaction. There are 2 moles of hydrochloric acid for every 1 mole of calcium hydroxide. And so we take our moles of calcium hydroxide, multiply it by the molar ratio, and that gives me moles of hydrochloric acid. So now I know I have 0.0250 moles of hydrochloric acid. Again, twice as many of these as these. And then I just have to divide it by its volume in liters. And so we take the 0.0250 moles of hydrochloric acid, divide it by the 50 mils, convert it to liters, and that gives me the molarity. Do one more, just make sure you got it. What is the molarity of a 40 ml sample of a solution of sulfuric acid, which is neutralized by 80 mils of a 0.5 molar solution of lithium hydroxide? Again, first step, write the balanced neutralization reaction and write down the information that you are given. The information really kind of gives you a map. If I do liters times molarity, that will give me moles of the lithium hydroxide. I then can use that to calculate the moles of the sulfuric acid by using the balanced chemical reaction. And then I can figure out the molarity by taking the number of moles and dividing it by the number of liters. So it really is molarity to moles of base to moles of acid to molarity of acid. So again, liters times molarity gives me moles of the standard, the one that I know both the volume and the concentration of. And so 80 milliliters is 0.08 liters times the 0.5 molar. That means I have 0.040 moles of lithium hydroxide. Multiplying by the mole ratio, which is 1 to 2, that will give me 0.0200 moles of the sulfuric acid. And then I just have to divide that by the volume in liters. And so that must be a 0.50 molar solution of sulfuric acid. Once you see this process, there's a lot of writing here, but the writing betrays a simplicity of this problem. So can it be easy? The answer is yes. Sometimes, if the numbers are right. Here's the balanced chemical equation. Here's the same information given in that previous problem. Again, take the volume, change it into liters, take the volume in liters, multiply it by the molarity. Half of 0.08 is 0.04. Then I want to get to moles of this. Note it's a 1 to 2 ratio. So multiplying by that 1 to 2 gives me 0.02. So that's how many moles of acid I have. And then I have 40 milliliters. That is equal to 0.04 liters. And 0.02 is half of 0.04, and so that is a 0.50 molar solution. Thank you for watching.